Hello and welcome. My name is Elena Lubimtseva, and this is the first lecture in our class GPY 100 Physical and Environmental Geography. In this introductory lecture, I will speak about the subject and perspective of geography, and especially physical geography, history of geography, 5 themes and 4 academic traditions in geography and their importance in physical geography, as well as Sun-Earth geometry and its role in seasonal changes. First of all, let's define what is geography and what is physical geography. There are many different definitions, and all of them are correct. You can read them on your own. You can find a number of definitions in our book. What I would like to emphasize today is that geography is the study of patterns and processes associated with the Earth. It is about everything that we see on our planet. It's a spatial discipline. It's a perspective that seeks to understand patterns on Earth and the processes that create those patterns. Geography is concerned with where things are and why they are where they are. It is concerned with a variety of different processes and different patterns, processes that have created them. In the sense, geography is different from any other discipline. Biology might be interested in plants and animals. Anthropology or sociology might be interested in humans and their society. Geography is interested in all of this, but it's much more interested in the spatial perspective on everything. It doesn't have its own specific subject matter like in other studies, but rather its subject matter is the entire Earth and human society. And they are described and explained using the spatial perspective. So geography is really about the spatial geography, the spatial perspective on everything, rather than specific subject matter. Today, it is more appropriate to refer to geography as a transdisciplinary or interdisciplinary area of study, rather than a discipline of its own. Geography integrates a wide variety of different subject matter, both physical and social. Almost any area of human knowledge can be examined from a spatial perspective. Hydrology, climatology, biogeography, geomorphology, meteorology, pedology, they all are parts of physical geography. Just as social geography, cultural geography, economic geography, behavioral geography, political geography, and urban geography are all parts of human geography. Geography is seeking to understand how all these different aspects of our life and the physical environment interact and how they influence each other. So it is a very interdisciplinary and integrative area of study, which is extremely important for solving a variety of different social and environmental problems. Geography consists of 2 major subfields, such as regional geography and topical or systematic geography. Physical geography is a part of topical or systematic geography. Here are some examples of geography questions. Where can we find tropical rainforest? Where can we find deserts? Where can we find boreal forest? Why those vegetation zones have been formed in those particular locations? How this is related to climate? How this is related to landforms? What kind of weather conditions can you find in those areas associated with specific vegetation zones? What is land use and other human impact on those areas, and what processes have been forming those impacts? Sure, geography is a very modern discipline. It uses computer technology, GPS, satellite remote sensing, geographic information systems, computer cartography to help us to solve our day-to-day problems in the society or in the environment. But geography is also one of the most ancient disciplines that was well respected in ancient Egypt or in Babylon or in the Roman Empire and ancient Greece. Concepts of latitude and longitude that we use today in our GPS and GIS go back to many thousands of years, as you can see on this ancient map that was developed by Ptolemy. Let's talk about 5 themes of geography. They're relevant both for physical and human geography. These are location, place, human-environmental interactions, movement, and regions. Location can be defined in many different ways. We can talk about relative locations by describing where things are in their geographic context or in their relationship to other objects. For example, we can say that Lansing or Grand Rapids are located in the state of Michigan, or we can say that the state of Michigan is a part of the United States. These are examples of relative location. We can also define every location by its specific x and y geographic coordinates, the latitude and the longitude. This is an example of absolute location. This is how we define our location in the GPS. According to German philosopher Immanuel Kant, there are three types of human knowledge. First, there are disciplines that are concerned with their own subject matter, let's say biology or geology or sociology. Then there is history, which is concerned with time. And then there is geography, which is concerned with space, with spatial relationships, of everything that is examined by other disciplines. The second theme of geography is place. We can describe any place in terms of its physical and human characteristics. Physical and environmental geography is more interested in physical characteristics. The third theme of geography is interested in human-environmental interactions. These might include the ways how humans depend on the environment for life in different geographic regions, what kind of resources they use, how humans modify the nature, and how do they adapt to nature in different geographic zones. The fourth theme of geography is movement. This can be movement of people, movement of goods, or movement of ideas. Finally, the fifth theme of geography is regions. We can define a region in terms of its physical or environmental boundaries or political boundaries. We can refer as a region to a part of the country or a part of the earth, or as a country, for example, the United States or Australia or Brazil or the Great Lakes states. We can also define a region by the specific function, the so-called functional regions. Let's say the region which is served by Delta Airlines or by the United Airlines or by the local newspaper or by FedEx. We can also define the region in a much broader terms based on people's perspectives. These regions usually have very unclear boundaries and can be interpreted in many ways. For example, the Middle East, the South, the West. It can mean sometimes very different things for different people, yet we usually associate those regions with specific, loosely defined geographic areas. Speaking about geography, it is useful to remember about its four academic traditions. This includes spatial tradition. Geography is about space and location. Area studies tradition. Geography deals with regions and different areas. Human land tradition. Geography is dealing with human environmental interactions in different areas. And finally, earth science tradition. Geography describes the Earth and all the processes and patterns on the surface of our planet. Let's take a look at each of these traditions. So spatial tradition reminds us that the subject of geography is really the location itself. It's the reason why things where they are. Spatial tradition is the investigation of the phenomena of geography from strictly spatial perspective. The area study traditions reminds us that the geographical study is always focusing on specific areas, on regions. That this can occur at the local, regional, or global scale, but geography is always interested in specific areas and regions. The human land tradition reminds us that the geographical study is always focusing on human environmental interaction. And finally, earth science tradition. This tradition is best described as theoretical physical geography. So knowing about these themes and traditions of geography will help us understand, first of all, what is geography and also what is physical geography. In the second half of the lecture, I would introduce the science of physical geography. Our learning objectives for this chapter are to understand the scientific perspective of physical geography, to learn about the 4 environmental spheres of the Earth and specialized fields of physical geography that study them, to learn basic facts about the size, shape, and movement of the Earth, and also to understand the Earth-Sun geometry and the march of the seasons. I don't know if you would agree with me, but I would probably say that geography, and especially physical geography, is one of the most misunderstood disciplines by the general public. And many people just assume that geography is about where things are and about memorizing pictures on the maps and learning what is that the capitals of different countries or different states. Or at the very least, if we think about physical environment, we kind of think of them as just static collections of landforms and rocks and weather, but not necessarily understanding that the subject of physical geography is about the interaction. Physical geography also sometimes misunderstood in the way that it's thought just to be limited to human environmental interactions, but not necessarily all other interactions. And sometimes physical geography is thought as just a discipline as a part of the social science rather than physical science. Finally, physical geography sometimes is just perceived as relatively unimportant middle school discipline. And sometimes it might be tempting to think that we know already most of this stuff. Or it's not terribly important for your future career, life, salary, family, dreams, and so on and so forth. In the reality, those are truly misconceptions. We do need to know physical geography in order to make sense of what is going in our life and what is going on our planet. The truth is that physical geography is a scientific discipline that helps us to see the world as a complex system, not just a set of unrelated features such as landforms and weather and hydrosphere and soils, but also to see how all of them are interconnected and how they're affected by human activity. It helps us to see and understand the world in the continuity and also at a variety of different spatial scales. It also helps us to appreciate multiple complex connections in the environment and helps us to explain them and understand the way how humans are shaping this physical environment. Physical geography helps us to realize that physical environment is dynamic. It's not static. It's all about processes. It's not just about things. It's not just about stuff. It's really about the change. And it also helps us to understand that we are far from being the center of physical environment. We are just a part of it. The world is much more than just a stage of human drama for the human society. We are the part of the environment. And that's why to start understanding of our own life, our own community, of our role on the planet, our role in the universe, we need to start with understanding all these different connections. Physical geography helps us to understand our role in the world, and that's why it also helps us to shape the future of our life and our interaction with physical environment. Physical geography deals with all the spheres: the atmosphere, the sphere of air, the hydrosphere, the sphere of water, the lithosphere, the sphere of rocks, and finally the biosphere. And we are a part of biosphere, and biosphere, of course, the sphere of biological life, which is connected and which is a part of all these 3 other spheres. Physical geography includes a number of subdisciplines, including geomorphology, that studies various landforms and processes on the surface of the Earth, pedology, which is a science about spatial relationships related to soils, biogeography, that studies the spatial relationships and processes that affect plants and animals, hydrology, which is interested in the study of spatial relationships related to water and water resources. Meteorology, that studies the circulation of the atmosphere and weather systems. And finally, climatology, the study about climate and climate change. Because geography is primarily interested in the spatial aspects of everything, it is actively engaged with other disciplines whose subject it studies. For example, geomorphology is a part of geography, but also geology. Geology studies the form of the Earth's surface and subsurfaces, and the processes that create and modify it. That's why geography is interrelated with geology. Physical geography is also interrelated with biology and ecology. Ecology is the scientific study of the interactions between organisms and their environment, while biogeography is really interested in the spatial patterns of the processes that are studied by ecology. Oceanography is the science that examines biology, chemistry, physics, and geology of oceans. While physical geography is also interested in the oceans, but more from the spatial perspective of the oceanography. Geography also includes cartography. Cartography is the technique of making maps. And of course, physical geography and human geography heavily rely on the tools of cartography. And today, this is computer cartography and also geographic information systems, remote sensing, and other geographic techniques. And finally, geography is also very much interconnected with astronomy. Astronomy is the science about celestial bodies and the cosmos, and geography is interested in the ways how our planet is influenced by astronomical processes. So in this class, we are going to talk about the seasonal changes and climate change, and we would see that those things are also related to the geometry between the Earth and Sun, and those are the subject matter of astronomy. So as you probably know, our planet is about 4.6 billion years old, and of course at that time it looked very differently and its geography was also very different. At about 4.4 billion years ago, the young Earth had a mass similar to the mass it has today. And then the continents probably began forming about 4.2 billion years ago. And of course, geography at the time, again, also looked very different, and the location of different continents looked very different. Most of the Earth's early atmosphere was also very different of what it is today. It was formed during the first million years after solidification of the surface of the land, and the first atmosphere was composed primarily from carbon dioxide and nitrogen and water vapor. And then through the relationship of biological life, gradually the model atmosphere had been formed over billions of years and led to kind of the interactions between lithosphere, hydrosphere, atmosphere, and biosphere that we know today. The Gaia hypothesis formulated by James Lovelock suggests that there is such a strong interconnectedness between the biosphere and atmosphere and lithosphere and hydrosphere that you can think of the Earth as a superorganism regulating itself through all these interconnections. I recommend that you read about the Gaia hypothesis in the article which I have linked as an optional reading on the Blackboard. The shape of the Earth is called oblate ellipsoid, or perhaps the more correct, unique term that is describing the shape of our planet is geoid. Geoid is very similar to oblate ellipsoid, but it's unique. It also involves all the landforms on the surface of the planet. Oblate ellipsoid means that it's not really the sphere, it's the ellipse, right? It's oblate, so it's slightly longer along the diameter of the equator rather than diameter of the Earth between the poles. The equatorial diameter of the Earth is about 7,926 miles versus the polar diameter, which is about 7,900 miles. And the Earth is geoid, not ellipsoid, because it has all these variations of the landforms on the surface of the ellipsoid. So, for example, the height of the Mount Everest is about 29,029 feet over the average, over the surface of the sea. And then, on the other hand, the depth of the Mariana Trench in the Pacific Ocean is about 6,781 feet. It really makes the surface of this ellipsoid or geoid very uneven. Location, as you know already, is a big part of geography. So in order to determine where things are, we are using the system of geographic grid, the system of latitude and longitude, the parallels and meridians. I want to make sure that you all know those terms from the first chapter, such as latitude, longitude, parallel, meridian, poles, prime meridian, equator, the big circle, the small circle, the Tropic of Cancer, and the Tropic of Capricorn. So let's locate all these concepts on the map. Of course, the North Pole, the South Pole, the equator, which is the line of zero latitude, the prime meridian, which is the line of zero longitude, going through Greenwich, an observatory near London. Of course, those are imaginary lines that we use in order to determine location based on X and Y, based on the latitude and longitude. And then the Tropic of Capricorn and the Tropic of Cancer that determine the angle of the sun over the tropics. So those are today 23.5 north and 23.5 south latitude, respectively, in both hemispheres. And we will learn later that the latitude of the tropics is changing gradually over time as it's reflecting the so-called Milankovitch cycles. The shape of the orbit of the Earth revolving around the Sun is not completely a circle, it's actually an ellipse. And this means that the distance between the Earth and the Sun is different at the time of the perihelion, when it's the shortest, on January 3rd, 147,500,000 kilometers, versus the longest distance between the Earth and the Sun at the time of the aphelion on July 4th, when it is 152,500,000 kilometers. Four other important concepts are summer solstice, which is happening on June 21st, which is, of course, the shortest night and the longest day in the northern hemisphere, and the opposite in the southern hemisphere. The winter solstice on December 21st, when we have the longest night and the shortest day in the northern hemisphere, and the opposite is in the southern hemisphere. And then the autumnal and vernal equinoxes, respectively, on September 22nd and March 20, when we actually have the same length of the day and night both in the northern and in the southern hemisphere. And this is really how we are experiencing as a planet the march of our seasons, as different amount of solar radiation is reaching different sides of our planet because of the tilt of the Earth. And the tilt of the Earth is 23.5 degrees, right? This is the angle where we currently have the Tropic of Cancer and the Tropic of Capricorn. They determine the amount of solar radiation that reaches different sides of our planet. And so as the Earth is revolving around the Sun, it's receiving different amount of solar energy, touching it at a different time of the year. And this is leading to the sequence of our seasons: winter, spring, summer, and fall. So these annual changes in the position of the Earth on its orbit and its revolution around the Sun determine the amount of solar energy that is reaching different sides of the planet, and this is what is causing the march of the seasons. During the summer solstice, when the northern hemisphere is tilted towards the Sun, the North Pole is receiving the maximum amount of solar radiation. This is when we have summer in the northern hemisphere here in the United States, and then the Arctic Circle is experiencing 24-hour day. This is, of course, the time of the 24-hour night over the South Pole, and it's also the time of winter over the southern hemisphere. Of course, during the winter solstice, this is just the opposite situation. The northern hemisphere is experiencing winter. It's tilted away from the sun, and this is when the sun is hanging over the Antarctica, which is exposed at 23.5 degrees towards the sun and is experiencing 24 hours of the daylight. And this is when the northern hemisphere is experiencing winter, and we have 24-hour night over the North Pole. During the equinoxes in fall and in spring, the circle of illumination is actually going through the poles. So both sides of the planet are experiencing 12-hour long day and 12-hour night because we have this equal exposure to the sunlight both in winter, both in the northern and in the southern hemisphere. So during the summer solstice in June, the Earth's North Pole is tilted 23.5 degrees towards the sun relative to the circle of illumination. And this is when we have summer, of course, and this is when we have the longest day and shortest night here in the northern hemisphere. During this time, all places above a latitude of 66.5 degrees north are in 24 hours of the sunlight, for example, in Alaska or in northern Canada or in northern Russia, while locations below a latitude of 66.5 degrees south are in a complete darkness in Antarctica. During the winter solstice, the situation is just the opposite. It's the North Pole, which is tilted 23.5 degrees away from the sun relative to the circle of illumination. This is when we have in the northern hemisphere the longest night and the shortest day, and at this time all places above a latitude of 66.5 north are in a complete darkness, while the locations south of 66.5 degrees receive the maximum amount of sunlight. So this is summer in Antarctica and the Arctic day in Antarctica. In spring and in fall, we have vernal equinox and autumnal equinox. So during the equinoxes, the axis of the Earth is not tilted towards or away from the sun, and the circle of illumination cuts through the poles. This is the time when the length of the day and night are exactly the same, both in the northern and in the southern hemisphere. So here are a few important concepts from the chapter that I want you to remember. First of all, the perihelion. The perihelion is the point in the Earth orbit when it is closest to the Sun. It's approximately 147.5 million kilometers. Perihelion is occurring on the 3rd or the 4th of January. Aphelion is the opposite. It's the point in the Earth orbit when it is the most far away from the Sun. It's approximately 152.5 million kilometers. Aphelion occurs on the 3rd or the 4th of July. We also need to remember summer solstice and winter solstice. Summer solstice is when the Earth is positioned in its orbit so that the North Pole is leaning 23.5 degrees towards the Sun. It's happening June 21st or June 22nd. And winter solstice is when the Earth is positioned in such a way that the South Pole is leaning 23.5 degrees towards the Sun, and this is happening December 21st or December 22nd. We also need to remember vernal equinox and autumnal equinox that are happening in March and in September. Although it might look right now that these concepts and numbers such as aphelion and perihelion, solstices and equinoxes remain the same, they actually change. They change slowly with the so-called Milankovitch cycles. Those are 3 cycles that are describing the relationship between the Earth and the Sun, and they're changing over time as 96 or 100,000 year cycle of eccentricity, when the shape of the Earth is changing and then the time of aphelion and perihelion are slightly changing as well. The second cycle is the cycle of tilt of the Earth, which is 40,000 year cycle. So today we know that our Tropic of Capricorn and Tropic of Cancer are located at 23.5 degrees. But this is not always the same, and in fact the tilt of the Earth can be changing from 25 degrees to 20 degrees. And finally, the 20 or 21,000 year cycle, which is the cycle of precession that is describing also the position of the Earth on its orbit as it's wobbling, moving around the Sun. All the three cycles, known as Milankovitch cycles, once again 96,000, 40,000 and 21,000 year cycles, are shaping the climate of our planet and are responsible for the sequence of glaciations and interglacials. They are not responsible for the current climate change that is caused by human activities, but they are responsible for the underlying cyclical climate changes, as they determine different amounts of solar energy that is reaching different sides of our planet. And we will talk more about climate change and the difference between the natural climate change associated with Milankovitch cycles and man-made climate change, which is associated with greenhouse emissions and other impact of climate change, in a few weeks.